So we're going to talk about our guitar effects pedal. And so if you zoom in right here, we have our guitar effects pedal. The green is our PCB, and then we have it connected to a Raspberry Pi Zero right here. And they're connected by a 2x20 header, and they're connected to the Pi's GPIO. And we have this cable right here, which is the micro HDMI adapter, which is connected to just an ordinary HDMI, and then that's connected to a HDMI to VGA adapter, and then that's allowing us to use this monitor. And so you can see that we need quite a few adapters with using the Raspberry Pi, which is a small disadvantage. And then so right here we have a micro USB port connected to, again, another adapter, which is connecting to the USB hub, which is allowing us to connect to a keyboard and a mouse, which is allowing us to, again, load the code onto our Pi, allowing us to program the effects. And then right here we have the true bypass button, which allows us to activate our effects, and then when we press it, when it lights up, the effect is activated. When it's off, then the sound is just true bypass. And right here we have our toggle switch, and right here we have our two configurable buttons. And then here we have the 1/4 inch jack input and output. Input right here, which is taking our guitar audio signal and feeding that through to this 1/4 inch jack input, and then that's getting sent through this board, through filters, and then to a Raspberry Pi, and then comes out to this 1/4 inch jack, and then gets sent to this amplifier, which plays the distorted effect. And Lauren is going to talk a little bit more about the pedal. So the pedal amplifier, which plays the distorted effect. And Lauren is going to talk a little bit more about the pedal.
So the pedal, we actually manufactured it ourselves. So there are some things that are drawbacks when you look at it. If you see, some of our parts are actually either surface mounted, such as this one, where it's not supposed to be. It's supposed to be through hole. And there's also another one where we actually had to solder wires to be able to fit into the actual hole. Mm-hmm. The reason this happened is because when we looked up the libraries for each part, the measurements of the drill holes were not actually correct. So when looking or when trying to redo the board, we definitely want to make sure we're using the same libraries. Another thing that we have to look out for is if you look closely, one of the wires is actually not angled at 45 degrees. That can also cause reflection and cause the amps to sound really bad if there is a signal going through. So in the future, we'd want to definitely make sure that's 45 degrees. We'd also want to make sure that when creating this, we accommodate for the height of each push pin. If we were to make a chassis, which we're developing that now since we have it all soldered up, but with the chassis in mind, these heights of these switches are all different sizes, so it'd be hard to incorporate a chassis that's tall enough to actually work with all switches, such as these ones right here. If I wanted to be able to access this, we'd have to make the chassis fit around this switch right here. One other thing is for these 1/4 inch jacks, because when the libraries were incorrect, we had to cut some of the pins. Although those pins were not needed, in the future, if we wanted to develop pins or connections to those pins, we'd want to avoid actually trimming them. Another thing about the board is the trace widths. I made it 13 mil, which is pretty standard, but for the power trace widths, I'd want to definitely make it larger trace widths so that way there is less resistance going through, and we're not losing so much power and losing so much signal. One thing Cindy had mentioned was we have all these adapters, and even though we have all these adapters, if you pre-program the Raspberry Pi
off. Yep, so now it's just clean. You can hear it amplified. And it's back on. Oh, and then the LED lights up too. Yay! Okay. This is tremolo. So this is just clean now, true bypass. And then turn it on again.